Okay, good morning. This is lecture 10 for CIS6395, the incident response technology class. I will finish the last section, last part for the network forensic analysis for this example. Then I will move on to next topic, which is static analysis of malware. Static analysis just means you do not run the actual code, suspicious code. Instead, you just use all kinds of software tools to see its binary code, to find ASCII strings in it, those kind of things. Just to make sure that the homework 2 is due this Sunday midnight. Okay, so let me continue what we left last time. Last time we mentioned that in order to find out what file has been transferred by the attacker, we know that AOL, when they do file transfer, they use this TCP port 5190 for the transformation of the file, transmission of the file. So we use this display filter, basically IP address related to N's computer, any traffic with related computer, and also if the port related to 5190. Remember, this is TCP dot port, so I didn't specify whether it's a source port or destination port. So basically, both direction of traffic, as long as this port is in either source or destination. Here it also means that either the IP address is in the source IP address or destination IP address. All those traffic will be included in this display filter. And we showed that there are not many packets in this connection because only 24 packets. We can see this SYN ACK. So these are the typical three-way handshake. So after the three-way handshake, the TCP connection, after the TCP connection set up, the client and server, they will begin to actually do data communication. So if you see the data, you will track the number 4 packet. Basically, immediately after the three-way handshake packet, the number 4 packet should have data in it. So if you click this packet, you can see that data, there are 256 bytes. Here is all binary things, so it's hard to see. But if you see this raw data, you can see that it has some ASCII string in it, OFT2. Then this is cool file export. So basically, that is AOL file transfer. It uses OFT2 protocol. Uses cool file transfer module to do this file transmission. And if you check further, well, if you want to check further, maybe you can just do this, follow any right-click any packet, just follow CP string. Then you can see this entire thing. So that belongs to the first data packet. Then this is the second data packet. We'll have this recipe .docx. Yes? Any questions? Okay, so that is a file actually transferred. However, this file transfer, remember all the FTP, when they do transfer, they will not transfer the file directly. They will, just like all the web page content, when it actually transfer on the internet, they will do some compression. So here, there are some compression going on. So you cannot see the actual file. And even if you see the actual file, you remember this is a Word document. Word document is not saved in ASCII format. It's saved in its own format. So you cannot see what is inside this one. But we can see this is entire thing transferred. So the blue part is transferred from the server, from N's computer to the other end. Then this is the from attacker's computer. Remember, attacker computer connected to the Wi-Fi. Attacker computer sent back this. So clearly that shows this is end of this file transfer. The file has been transferred, finished. So we know that this file name is recipe.docx. So that's another question information. The last question, question 4, what is the magic number of the file you want to extract? Magic number, you can, I think I probably mentioned last time. If you don't know, you just Google search magic number file, and you can see this Wikipedia page. So what magic number basically is the first few bytes, for any formatted file, and all the files, they have their predetermined magic number in the beginning. Some files they have two bytes, some files they have 4 bytes, some have even more bytes. So you can see that like a zip file, these are the 2 bytes for the zip file. And if you want to see Word, well, there are too many. So let me just find DOC, DOCX. Okay, so you can see that this is a zip. DOCX is DOC. This is by older version of Microsoft. But so the question asks you what's the magic number for this file, and you can check here. You can find that this is quite basically say what file you want to transfer, and this is actual file. So the first part is this. If you go check this packet, you can see this. This is this one. PK is a 554B0304. So that is this magic number. Let me see, how do you know these first few bytes are magic number? You can see this one, 54B0304. This is DOCX belong to this, and the other is also. So DOCX is a zip file format based on, basically because Word document, in the Word document, when it's saved on a file, on a disk, it actually uses this zip compression algorithm to do the file compression, to make it smaller. So zip file will have this 4 magic number. So all these, they have this first 2 bytes, they are the same, but the last 2 bytes, they are different. If we check our file here, you can see this PK, this one, 0. So the magic number will be this 4 bytes, 0304. So that is belonging. The magic number is actually this one instead of the following 2. If you want to check magic number for DOCX, Here is just some people ask the same question, but magic number for DOCX. Here is another one. The DOCX is this. So Office 2010 and up with DOCX file, the magic number is this one. So 54B0304. This is 0304. It cannot be represented by ASCII string. So in this in here, it was represented by just a dot dot. In the Wireshark, if a byte cannot be represented by ASCII character, it will be simply represented by dot. So that's the magic number for the file. Now we need to download the file. Because this file is transferred not in HTTP, Wireshark have included a few protocol, including HTTP. So you can actually download all the objects through HTTP when this object transfers through HTTP. But this is transferred through this OFT2 protocol. Wireshark has not built this protocol in, so Wireshark, you cannot directly download the files from the Wireshark. So we need to carve out the file from this packet capture. So that's something that is a little bit difficult. We can directly use Wireshark to carve out a file. So that's the direct approach. It's need a little bit operation. So you follow the TCP string, and then because we're interested in the file transferred out from Ann's computer, so you can basically show like we follow TCP string. We are interested in not both direction, which is interested in the file transfer. So file transfer is this one direction from Ann's computer. Remember, Ann's computer IP address is 158. So Ann's computer to the attacker's computer. Then these are all data transferred out from Ann. So these must contain that file. And we can see that these are the beginning part. These are beginning part basically for the OFT2 protocol, like say it's like hello message in OFTP protocol. Then the actual file of this recipe.ucs actually start from here, because these 4 bytes is the magic number. So that means that if we copy everything down from here, we need to first remove the beginning, these many bytes, because the actual file start from these 2 bytes. So first we need to save that down into a file. So we only need half duplex flow from the source IP of this one. So that's 12 kilobytes. But when you try to save that, you should save the data as raw data, not save it as whatever displayed. Because whatever displayed here, you can see that here is just all the dot, but actually there are data there. So instead of this display is just for human to read. So instead of show data as ASCII, we show data as raw. So this is actual raw data. But basically, every 2 digits represent 1 byte. So that's the hexadecimal representation of that 1 byte. Then we try to save the data. We try to save the data like so save the data as the raw data. Then we need to carve out, just means that the file is just in one part of the whatever you have saved. You need to remove all the unrelated part from what you saved. The remaining will be that file. But the file still contains protocol exchange information in it, because if we show them as ASCII, you can see that in the beginning, this is the protocol exchange information, and in the end, well, the end doesn't have protocol exchange information, because if we show two directions, you can see that this is protocol exchange information, and this is the response to end of this protocol exchange. So we needed to remove the unrelated bytes. How do we remove it? We can use a hex editor. Basically, that's it's like a raw file editor. It doesn't display the file in ASCII format, just display the file into this byte format. You can use any kind of hex editor to do that, or raw data editor. So I have downloaded this B hex editor. To do that, you can go here to download the one. And so this is the one I have downloaded this Bean hex editor. It doesn't need to install, you just download and you can directly run it. So this hex editor, we open whatever, we just download this raw data. Then you can see that this is a hex editor, basically binary byte by byte display. So this part display this hexadecimal value for every byte. This part will display just like Warsaw. If that byte has an ASCII character string to represent it, it will show the letter. Otherwise, it will show just a dot. So you can see that the recipe is here. If we want to find, well, this is magic number, remember PK. So this 4 bytes is a magic number. So we need to remove every single byte before this magic number. So we need to select all these bytes. Then we can just say cut. iPhone. And the first byte should also be removed. Okay, now you can see that this after I carved out the things, the start from 554B 0304. So that's a magic number for this file, and everything is done. Remember, there is no end of protocol communication, so we don't need to cut anything at the end. Now we can save it. We can save. So this is saved, just a save to the original file, and so now we can rename it. Rename like DOCX. Now we can see whether we can actually see this Word document. Well, you can see that we actually successfully recover the Word document. Of course, if you want, you need to change the file to be original file name. So that's the secret document download by the attacker. So you use a hex editor or raw data editor, you cut out all those unrelated bytes from the saved raw data. Then that will be so this operation is called carve out, and show the start of the document. The start view byte should be the magic number. Then it will be done. And question 5 is, what was MD5 hash value for the file? Remember, MD5 is calculates the fingerprint of a file, which is usually used for digital signature purpose. So there are multiple ways to do it. On Linux machine, Linux has this MD5 sum program. So you can directly use MD5 sum program on the recipe.docx, and it will generate the MD5 hash value. So the answer to this question 5 is this MD5 hash value. If you don't want to use another operating system, suppose you do this, everything is on your host Windows machine or MacBook machine. Another way is that you can use online MD5 calculator to do this. There are many online websites can do that. So like you can just Google search MD5 calculator. And there are many of them, so you can use anyone. So let me use the first one. So you first choose a file to upload. Then it will give you this file checksum in MD5. If you want to calculate the hash value for SHA-1, you just select this. This is SHA-1. This is SHA-256 hash value. So this is MD5 hash value. So that's the answer. You can copy this for this question 5 answer. Carve-out file. Another is that you can use some user programmed tools like TCP extract. But I tried it on Linux. It's not that easy to use. It's just some user did the program by themselves. It's not well maintained. So it's not very easy for this TCP extract. Another way you can use some additional software. For example, this is one of this network forensic. This is network forensic tool. It's called Network Miner. It's like a Wireshark, but Wireshark is open source, a free software. So many people use it. Another is Wireshark is a general purpose network traffic analysis. This network miner is more focused on forensic analysis. So it's you can think that it's a specialized network traffic analysis software. It's a commercial software, but it has a simpler version you can download. And I have downloaded this. So the usage is very simple. You just open this network miner. You open that file trace. Remember, this is forensic analysis. So it doesn't do actual real-time network capturing by itself. It needs to open a saved network trace. For example, you use Wireshark or some other network software. So it just open a network trace. So this is evidence that network trace. Then it will give you all the related forensic analysis of this network trace. Basically tell you how many hosts have connections in this, how many files has been transferred, and this will show what file can be recovered by this forensic analysis software. So in the 3 files, this one is recovered one. Is one of the recovered one. It shows that TCP 510, and the file name is recipe.docx. Now you can just right click and save it. Actually, it has already saved. You can open the folder. So this is network forensic. It just show the all the analysis, the information is saved in those folders. So this is the recipe. You can directly click. You can see that this file is directly come out. So network miner understand this OFT2 file transfer protocol, so it can carve out, it can directly extract the file from this OFT2 protocol. It's just like Wireshark understand HTTP protocol. So for any file transferred through HTTP protocol, Wireshark can save all these files, extract them, and save them. Network miner understand this FTP protocol, so it can directly extract the file. So you see that it's very simple. And of course, network miner give you some other information, like what are the message, because it also understands AOL protocol, so it showed all the message in AOL, like from to this, all these message, credential, what is login, and sessions. There are 6 TCP sessions going on. So all these and anomaly, there's no anomaly in this traffic. So this is a commercial software. So it can get this file directly without any problem. Of course, this is only for forensic analysis, so it's not as general used as Wireshark. Okay, any questions for this forensic puzzle introduced here? Okay, let's move on to the next topic, which is malware static analysis. Oh, because in malware static analysis, we need to try several open source software or free software. And even though my slides have the download link, maybe it's not safe for you to download, go to those page, because some of those web pages, they have advertisement. So if you're not careful, you may accidentally click some advertisement, download some unrelated software. In addition, for those open source software, it's better not to run it on your own host machine, because you really don't know whether that open source software has some adware or some other malicious code in them. So you should install those open source software on your Windows virtual machine. Those software, they are all for Windows machine. Even if you are using Windows host machine, don't try to. I don't recommend you to install on your own host machine. So I put all these download softwares into this zip file, so you can go to your Windows 7, Windows 10 virtual machine, and visit the web course and download this one. And I will use Windows 10 virtual machine as an example. And before you use Windows 10 included this network Microsoft Edge to browse the internet, the first thing you should do is download an updated browser. For example, you can download Google Chrome or Firefox, because the Windows virtual machine included the Internet Explorer, they are not up to date. So you have to update them first. For me, I think download Google Chrome would be the easiest way. So once you finish downloading and install Google Chrome, you can use the Google Chrome to visit your web course. So that in that way, it will be safe. You then visit your web course, then download all this zip file. Okay. Again, I says some slides. I used some slides from Dr. Lang's previous teaching of this class. He retired a few years ago, so I used some of his slides. And I also use some slides from this Stanford class. Again, this class, it has put their lecture notes online, so you can, if you want, you can go to this this URL to see their lecture notes, other lecture notes. So let me, for example, you copy this URL. And you can see this is an older version of their class, 2009. Maybe their new one is out. So let me check. No. Okay, so you can see that spring 18. So until spring 18, it's posted here. So you can see this spring 18th more information. I don't know if they put their lecture notes here or not. At least they put their homework and project here. Class overview. This one doesn't put lecture notes. This one doesn't put lecture notes in. On the page, it doesn't put lecture notes, but some slides, it should be in lectures. So that's the folder. It doesn't. Let me try this lectures. Okay, there's no such. So some of them, they are not publicly available on the page. But anyway, you can download these PowerPoint slides. It's still on their website. It just doesn't have a clear, explicit URL link on their webpage. This one is from a security company. They give us some tutorial information. It's from a security company, and but the webpage contains some tutorial information that is useful. Like this is a tutorial master 4 stage of malware analysis, and you can read this simple white paper to see what's their explanation, what's the process for you to analyze the malware. So I used some of their content in this lecture. So malware is a generated word by computer science people by combining this malicious software together. Let me see available here. Oh, okay. Thank you for this. Okay, so this is lectures. So I think I made some character wrong. So you can see their 2018 lecture slides. Let me put it on the. Okay. I will update web course with this updated slide, so you can see all the spring 18th lecture slides here. And basically, malware just means any software program that doesn't have that have some malicious intent. So that's called malware. For example, computer virus, that's the first type of malware appeared in computers. Then when the internet become more and more popular, when most computers, they are connected to the internet, worms become the major threat more serious than virus, because worm is a program that can actively transmit itself over a network to infect other computers without human intervention. So virus, on the other hand, it needs a human's interaction to transfer from one file to another file. For example, human copy the file to a USB key, take it to another computer and put the file in another computer. Before all the computers are connected by internet, so that's the only way for a virus to spread out, rely on human intervention. But when computers are interconnected with each other, and when many computers, they are always online, especially those servers, then worm becomes the major threat, because without human intervention, it just means it can spread out as fast as in the computer speed. So a worm can infect almost all the vulnerable computers on the internet within a few hours. So that's how quick a worm can spread out. Trojan house, this means the malicious program disguised as something useful or desirable by a user. For example, if you download some free software, open source software on the internet, you may download one that, well, for example, for compression software, you download one. It may do this decompression successfully for you. But underneath, it may have a Trojan house, a malicious code inside. It will do its malicious action in the background. So that's the Trojan house. Spyware keylogger just means attacker, once this malicious software running on your computer, it silently collects your computer's information. Like a keylogger basically collects all your keystroke on your computer. So then the keylogger can send this keystroke data to attacker from time to time. Why this is useful for attacker? Because when you log in to your, for example, your bank account, your credit card account, then they will know your password, because that is what you typed by your keyboard. Spyware can collect more information, some other information from your computer. Backdoor just means, especially some virus or worm, once it compromises your computer, it will set up a simple, for example, telnet server, a remote login service running on a specific port. Usually it's a very high, bigger port. And that is called backdoor, because this backdoor, either that it doesn't require any remote connection to use password. So anyone can log in through that backdoor remote login service to log into this compromised computer. Or this backdoor will have a preset account that is only used by that malware also. So once attacker leave a backdoor on your computer, attacker can log into your computer whenever they want. So that's the backdoor. Rootkit, it just means malicious programs that try to hide itself to avoid detection or disinfection. So rootkit, you can think that it's a more advanced malware. Once it compromises your computer, it will try to erase its trace. For example, modify the computer's log file to remove all these previous attacking attempt from the log file, and hide it inside some kernel area. So you will not be able to discover that this program is running in the background. So that's the rootkit. The first virus is in 1980s, early 1980s, by this Fred Cohen, and it set out based on Linux computers, because at that time the computer only connected to internet is Linux computers. The first mobile phone virus appeared in 2004. The first widespreading worm appeared in 2001, which is the code red worm. We will use this one as one example when we do this static analysis. Code red worm opened the eye for all the security community, because before this one, the only malware widely spread is a computer virus. And there are already some computer virus, antivirus company, they generate virus software, antivirus software, you can install it on your computer. The virus, antivirus software will periodically update with a new signature of virus. So people feel that, well, that's enough to dealing with the security attack. But in 2001, this worm appeared and finished infection. Remember, just a finished infection within just 10 plus hours, just a little bit more than 10 hours. It finished infection all the vulnerable computer on the internet. So that's not, so for traditional antivirus software, it's like an antivirus software company. They discovered a virus, then the human expert in that company, they analyze the virus, extract the signature, then put in the signature in their database. Then after some time, they will push out this new signature to all the antivirus software their customer have purchased. So that will take weeks for this virus signature to appear in all the computers. This worm finished infection within a day, within half day. So it certainly means that traditional antivirus is not good enough. It cannot catch up with this the speed of this worm. So that opened the worm infection stage. And basically after 2001, there are several global scale worm incidents. For example, 2004, actually there are more than that, but in 2004, this is a mass mailing worm. Mass mailing worm, it just means once this worm compromise your computer, it will extract all the email address it can find on your computer. Then it will send out email to all this email address. In the email, it will have the attachment. This attachment is the worm itself. So if any recipient of those email click that attachment, that computer will be compromised. So that is called a mass mailing worm. And this worm compromised several millions. Some people say it compromised 8 million Windows computer. Because at that time, people don't aware that the email attachment could be harmful to their computer. So what to be infected by malware? Malware can infect these things like executable, so that's the most common one. And master boot record. This is not popular right now because we don't frequently reboot our computer. In the early stage, every user, when they open their computer, they basically need to reboot their computer. Then this master boot record, this will have this boot up program. So malware, they can try to put itself in this boot record. Then every time when you reboot your computer will first run the malware code first. Hypervisor is a malware could infect in hypervisor, for example, VMware VirtualBox. Then it can in turn compromise the virtual machine running on those hypervisor. There are several formats for malware to exist in computer. First, it can replace a target executable file. And of course, this malware will use the same name as this target executable. For example, this target executable is like Acrobat Reader. The malware can name itself as Acrobat Reader just to replace the original Acrobat Reader from your program, from your file system. A malware can append itself at the beginning of this executable. So when a user executes the host program, this original program, the malware code will first execute. Then the malware will pass execution to this host program. So this is like a Trojan horse, like when you use like image processing software. The image processing software is doing all the functions that you want. It can do all this processing, but you don't know that when you run this image processing software, the malware code will first run and run it in the background. And a malware could append at the end and only has a jump instruction in the beginning. Because this, if the malware always exists in the beginning of any executable, it's very easy for antivirus software to detect. Antivirus software just to check the first several instructions, executable instructions in any executable file. And they can find that, well, there is a malware in the beginning. So malware will do this. It will append at the bottom, only has one jump instruction in the beginning. So if antivirus software only do static analysis, like still just check in the beginning part, they will not be able to find the signature for that malware because the malware code is at the bottom. Yes.
This diagram in reference to like installing the executable?
This diagram just represent how a malware, once a malware compromised an executable program, where does the malware code exist? Because for antivirus software, they will check, for example, when you do a quick scan of your computer, antivirus software will check all the executable program, but they may not static analyze entire part of the executable program because your computer have thousands of executable program. It usually just check the beginning, like several hundred bytes. So in that case, this malware can be found because malware has a distinct signature. The antivirus software has already built that signature in its database. But this one will be harder to find if the antivirus software does not check the entire content for the executable code. It will not be able to find this malware. And malware could insert itself in the middle of the target executable for the same reason as this one. And for more advanced malware, malware can try to separate itself into smaller pieces and insert every piece in many sections of the original executable. This is try to avoid being detected by antivirus software based on signature. Because if you split yourself into many small parts, you don't have a clear signature anymore. Another way for malware to exist when it appends itself to an infected host executable is that it can come up with a packer. A packer, you can think packer is like a zip, is a compression program. It's a simple compression program. So packer has its legitimate use, just like all the compression program. Remember I said that for web transmission, all the web server, they put their file in compressed format. Even the Word document, Word itself will do a compression of its content. So packer is like compression. So it will make this executable file smaller than its original should be. So in that way, a user can download this executable program using fewer bandwidth. So that's a legitimate use for packer. But attacker could use the packer for the purpose to hide the signature of the malware, because packer is a compression. So once you do a compression on a malware code, the signature of the malware will be compressed as well. So you will not be able to find original signature for the malware anymore. Remember, signature is what I mean is a static analysis. If you just like a magic number for any file, you have the first few bytes magic number tell the file type. If the magic number is the first few bytes, they are compressed, then you will not be able to see the magic number anymore. And for attacker, when they use packer, they can do not only the legitimate use of the compression, which is a legitimate use, it can also do encryption because packer program provides that function. It can do randomization. I will explain randomization later. Anti-debug. Because some packers, they can first determine whether it is running under a debugging environment or not. If it's running a debugging environment, it will stop execution. So if you want to debug malicious code, it will not run. Anti-VM is similar in the same way as anti-debug. Anti-VM, it just means before the code, the program execute, it will first have some instruction to check whether it is running under a VMware or VirtualBox environment. If it finds out that it is running under a virtualization environment, it will stop its execution, or it will not run those malicious code. It will just run the normal code. So you will not be able to discover that this is malicious code. So that is the anti-virtual machine. So that's the packer. So this one give a cheat sheet for reverse malware detect. So I summarized this cheat sheet for detecting, for analyze malicious software. First, you set up a controlled, isolated environment in which to examine the malware. Suppose you find out a program is suspicious, maybe it has malware, then you should do this step by step. Most likely, the first step just means you run a virtual machine. So that's why this anti-VM function, attacker use anti-VM function. You do perform behavioral analysis to examine the specimen's interaction with the environment. So that's something like a dynamic analysis. You run the code to see whether it generates network traffic or not. Of course, this controlled, isolated environment, virtualization environment, should have no internet access. Otherwise, the code may send out malicious traffic. You perform static code analysis, which is what these slides talk about. Further understand this program, then you can perform dynamic analysis. Dynamic analysis, basically, you run this program. Most likely, you run this program under a debugging environment. Of course, you should always run it in a virtualization environment. If necessary, unpack the program. If you see this program is packed by some packer, you first unpack the program to recover the original program. Then you just repeat these several steps until sufficient of analysis have been met. Then you document your finding, then clean up the laboratory. For virtual machine, just means you can delete your virtual machine. Type of computer code, any executable code, when we say executable code, it doesn't mean that this executable code must be in machine code format, because some executable code, they are running under their specialized environment, so they could be in this source code format. For example, JavaScript, you can think that, well, this is a executable code, but JavaScript, you can clearly see the source code of it, because JavaScript is running under this Java running environment, so it doesn't need to generate a binary code. So this like a Java code, it exists in this source code format. Some other code, they are in compiled binary machine code format. For example, this .exe file in Windows machine, they are executable code. Some other code like shell script, they also exist in this source code format because they're running under this shell or like a Python program. It also exists in this source code format. It doesn't have a binary format. Because they are interpreted language, when they run, they are not in this compiled form. Static analysis just means you analyze this malware code without running it. So static analysis usually it's safer to do because you are not actually running the program. So there is no harmful for you to do any static analysis. You don't need to do this static analysis in a virtualization environment, for example. You can do it on your own host machine. So some question to be answered, like what type of file is this? Like whether it's in this batch file or shell script or JavaScript or Windows executable or Linux ELF is a Linux executable file. And what does this program do? Without actually running the program, you static analyze to find what's the behavior of the program. Does it spread itself with physical media or network resource? Does it alter or steal or delete anything on your computer? You determine the type of file you are examining. You review the ASCII string in it. Because for many binary programs, even though it exists in the binary format, it still have a lot of ASCII string in it. Because the program may have some printout of some text, then this text printout will exist as ASCII string in this binary program. So if you check those ASCII string, you can figure out part of the information from this program, like what kind of printout this program could possibly have. You can submit the code to a virus program, antivirus, not to virus program, but antivirus program. Or to some online scanner, like a famous one is the virus total. So if you So this virus total is like you can upload a local file. The virus total will run many antivirus software to analyze this upload file and tell you whether this file has any malicious code in it or not. So that's the online antivirus. This is a free service that you can use. And perform additional online search to find out what this malware is, whether it's a variant of some well-known malware. So if you want to do malware analysis, you need to get some malware sample to do some tests. So where to get malware samples? Again, from Zeltester, this website, it tells some free malware sample that you can download. Like these are some websites that have malware samples that you can download. Many of them require you to register an account, but some of them don't require you register account. For example, this one contains more than 100 malware binary. The good thing for this one is that it contains some source code for some malware. For example, code red worm. it's very old, the first generation of the internet worm. So people, researchers have both the source code and also the binary code for code red worm. The first one, static analysis, is to find out ASCII string in this binary program. Suppose what you have a malicious program is in binary format. You first use to find ASCII string. This file command is in Unix command, but you can use like a hex editor to open. Remember, I said this hex editor can open a raw data. So you can check the first few bytes. Then, based on the magic number list, you can find out what this file, what's the file format, what's the file type for this one. And the hex editor can also find all the ASCII string in it because it will display them in the second window. If you want to display ASCII string, there's another command. It's called strings. It exists both in Windows and Linux, and it will show all the ASCII string that is longer than 3 bytes. So there could be many ASCII string that is only 3 bytes. Doesn't make any physical meaning because those are not real ASCII string. These are just happen to be that the 3 consecutive byte, they can be represented by ASCII character. So string can show that. This is one option to look for all sections of the object file. I will explain. A binary program doesn't have one section. It is also formatted file. It has multiple sections in it. This syntax is find ASCII and Unicode string in them. I will demonstrate them a moment later. So I will not show how to analyze the Linux malware because most of the malware, they are Windows malware because Windows is a major target because many users use Windows machine. So we will just show static analysis for Windows malware. And for static analysis for Windows program, Windows executable program is called portable executable. It's called PE. So you can think that that's the first 2 bytes for Windows executable. Here, the link showed what's the 5 analysis tools worth to look at. In this class, I will demonstrate these 3 software tools. You can download them from this place, or you can remember I have downloaded them and put them in the zip, so you can download this zip and install them on your virtual machine. You don't need to install them on your host machine. Windows executable is called a PE file because the first 2 bytes, the magic number for Windows executable is always PE. Start with this with these 2 bytes, so it's called PE. In Linux, the executable is called ELF file, so that's a Linux. Macintosh, it has its own executable file format. Windows executable file, a PE file contains a number of headers and sections. So that will tell you the information. So these, you can think that this is a Windows executable program. The executable program will have many sections. And here you can see this header. This showed how, what's the sections in this executable. Like an executable file could have a debug section because when you compile and generate the Windows executable program, you can generate a debug section to put the source code in this generated executable program. Of course, all the commercial software, they will not put the source code in their executable program because they want to keep the source code to themselves. But for some open source software, when they generate executable, they actually put their source code in as one component in the .exe file. So that source code is in this debug section. So debug section also contains some other information that can help you to debug this executable program. This here explain what each section means. This text section will actually hold the program code. So the actual binary, the machine code for this executable program, they actually in this .text section. So only this section contains the executable program. .data section holds the global variables. So you can see global variable, because when a program running in Windows machine, the global variable will exist in its own memory place. The other section is harder to explain what they have. And header also have this file header. So basically P something. So that's the magic number for this. This DOS header will contain, DOS header is start with these 2 bytes, MZ. Basically, DOS header will tell you whether this program can run under a DOS environment. DOS environment just means this environment. If a program can run under this environment, then it will definitely have that DOS header. It will definitely have this DOS header section. Windows executable actually exists in 2 formats. One is EXE. EXE is a standalone executable program, so you can execute this EXE by itself. Another executable is the DLL format. This is a dynamic link library. Even though they are executable, they don't run alone by themselves. They exist in the memory, and it can be called by some other program to run the executable module in this DLL place. So dynamic link library, so that's the Windows implementation. So because the code in a DLL is usually shared, so it usually exists in the memory, so any other program, they can call those DLL module and run. So it's like a shared running program. Usually it's like a kernel program. Many kernel programs they exist in this DLL format. So it is not possible to directly execute the DLL. DLL need to be called by a standalone EXE program. So EXE program will use an import address table called IAT table. This import address table will list all the reference DLL that it might call at runtime. So this IAT will be read and analyzed by the operating system. So it will know that what kind of DLL module this running program might execute. So it can prepare this DLL for this executable program. It's filled with appropriate address. So that's the import export. So this IAT information is saved in this R data section. So when we do actual illustration, we will use 2 malware for illustration. You can download these two malware here and here. The two malware, they are in this zip format because they are zipped by a password. Why we need to do zip by a password? Because if you don't zip with a password, when you download it, your antivirus software will be able to unzip it, because zip is very common compression algorithm. All the antivirus software, they can unzip. Once they unzip, they will check the signature and quickly find out that this one has a malware signature in it. Then it will stop this downloading. So right now, it seems I can download because this zip is a password zipped file. The antivirus software cannot unzip it because it's password protected. If I unzip it, like extract file, I need to input the password. The password is infected. So let me say show password. So this one I can unzip successfully because the code red is too old. Its signature does not exist anymore on the antivirus database. But if I download the other one, this one actually download failed. You can see. You can see this it's virus detected. So even though it is zip password, but I think because this password is used by all the malware code, so this antivirus software can try that password and can unzip it, so it can be find out this, because the second one, this my Doom, its signature still exists in Windows Defender's signature database. So Windows Defender is able to detect. So you cannot download it on your Windows machine. So in order for me to download on my Windows 10 machine, I actually disabled my Windows Defender's virus protection part. It was allowed the download. Oh, okay. Because some software, they don't have this older malware signature in them. The code red worm. Right now, my computer is allowing me to download the code red worm code because it doesn't have the signature in it anymore. Windows 7 VM, I think the Windows 7 VM allow you to download because Windows 7 VM, this Windows Defender in Windows 7, it cannot unzip that password protected zip file. Remember, this password is password protected with infected password. The Windows 7, it doesn't know that password. But Windows 10, it knows that many people download this zip file with that password. Because this malware, right now it has been disabled. It was disabled out of service by 2017. I don't know what's the reason, but maybe one reason is that it is so popular. Many people download existing malware from this place. All the malware that you download from this place, they are zipped with this infected as a password. So maybe because of the objection, so this website is out of service from 2017. But that means the Windows 10, this antivirus software, it knows that many people download this zip with this infected password. So it can actually decrypt this password protected zip file. So it finds out that worm signature in it. So in order for, if you use Windows 10, so one student said, if you use Windows 7 VM, you can download this zip file. If you use Windows 10, you cannot download. It will just appear in the same way as this. It shows the download fail virus detected, so you will never be able to download. You can disable your Windows Defender, like you go to your, remember this is virtual machine. You go to your start setting and go to this update and security. You go to your Windows security and virus protection. Then you click this manage setting, virus and threat protection, and you can make this real-time protection off. If you make the real-time protection off, then you can download the zip file. If you do this, then you can download the zip file on your Windows virtual machine. If you don't know the steps, you can Google search how to disable Windows Defender Windows 10, how to disable Windows Defender in Windows 10. Then it will tell you how you can disable this. Once you disable this, you can download this two malware code into your virtual machine. Okay, I will explain how do you analyze these two malware next time. But you can download them on your virtual machine. Don't download them on your host machine. Okay, that's all for today's class. See you this Wednesday.
Thank you.
Thank you.
Thank you.
Thank you. Bye-bye.
Thank
Bye-bye.
you.